different curves using the parent function, using the standard values that you should know going 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so in particular, when you look at the amplitude of this function, the amplitude is 3, and it's really a vertical stretching factor. So what that's going to do is it's going to take all of your old y coordinates and it's going to multiply them by 3. So 0 times 3 is 0, 1 times 3 is 1, 0 times 3 is 0, negative 1 times 3 is negative 3, and 0 times 3 is 0. So again, what I did there was I took all of those y values and I used that 3 out in front, multiplied them all by 3. Okay, on the other hand, when you look at the phase shift here is a plus pi, so that means everything got shifted to the left. Pi got subtracted by pi. So that means that on the x coordinates I need to shift everything left pi. I'm going to subtract pi from all of these objects. So 0 minus pi is negative pi. Half a pi minus pi is negative pi over 2. Pi minus pi is 0. 3 pi over 2 minus pi would be a half a pi. And then 2 pi minus pi is pi. So we've moved all of those x values and we've done a horizontal shift to the left pi many units. And now this puts us into a situation where we're ready to graph. We can graph very nice, very easily right now. So we need to go back to negative pi. We have to go negative pi over 2. We need a 0. We need a pi over 2. And we need a pi. And then along the vertical axis we need 3 and negative 3. So 1, 2, 3. 1, 2, 3 to negative 3. That should be a 0. That's not clear. Okay, negative pi. Now looking at not the black, not the stuff in the black, but looking at the orange and the red as my graph, I need to go through negative pi comma 0, negative pi over 2 comma 3, 0 comma 0, pi over 2 comma negative 3, and then pi comma 0, which means that this sine curve is going to look something like that. And that's one graph of one period of the 3 sine x plus pi type graph. So why don't you pause the video and try this next one on your own. Give you a cosine curve over here. Try to use the same analysis. And assuming you paused the video and did try it on your own here, that 5 halves would have changed all of the y's by multiplying by 5 halves. So you would get 5 halves 0, negative 5 halves 0, 5 halves. Then on the x's we have a shift to the right, a phase shift of half a pi to the right. So moving everything to the right pi halves would give us half a pi, pi, 3 pi over 2, 2 pi, and 5 pi over 2. So now when you come together to try to create the graph, we're going to have a graph that kind of starts at pi halves and it cares about pi and 3 pi over 2 and 2 pi and 5 pi over 2. On the vertical axis it's going to go up and down 2.5, so 1, 2, 3, and that means it's only going to go up to about here, and 1, 2, 3, negative 3 on this end is going to put us about there, and pi over 2 is going to give us 5 halves, pi is going to give us 0, 3 pi over 2 is going to go down to the bottom to negative 5 halves, 2 pi is going to be 0, and then this one's going to be back up at the top. So the graph of this cosine curve for one rotation should look something like that, and like that. And that's one rotation or one period of the cosine curve in this context.